Solving systems of equations by elimination. In the technique of elimination, the goal is to do exactly what we just said. We want to eliminate one of the variables. Remember that if we have two unknowns, in this case x and y, we need two equations. So I want to eliminate either the x or the y and leave myself with only x or y. It's sort of similar to substitution, but a little bit of a different process, wherein we have two rows. I'll call this one row 1, the top one, or R1, and the next one row 2, or R2. And we're allowed to multiply each equation by a number. We're allowed to rearrange the order of the rows if I think that helps or makes it simpler to see. And we're allowed to add or subtract these rows together. In fact, we can do a combination of these things. So what I'm going to do, I'm going to leave my row 1 alone. And then I'm going to look at row 2, and I'm going to multiply everything by 2, giving me 8x minus 2y equals 18. So I took this entire row 2 and multiplied it by 2. Now, why did I do this? Well, it's going to help a lot if I add these two rows together now, these two new rows. So I can add my x's, giving me 11x. I can add my y's. 2y minus 2y is 0y, and notice that I have eliminated the y. And then I could add the numbers. And that gives me x equals 2. And once I know x, I can back substitute into any equation to get y. I'll put into the top equation, the original row 1 up here. And I get 3 times x, that is 3 times 2, plus 2y equals 4. So we get 2y equals 4 minus 6, and y equals negative 1. So we get the solution 2 comma negative 1. All right, let's try another problem. Let's do x plus 2y equals 4. And 3x plus 3y equals 10. Now, if you already watched the video on substitution, I did this problem, so we know the answer. But if you don't know the answer, no worries. Can you think of what I might do to eliminate a variable? First of all, which variable in this problem do you think is easier to eliminate? Do you think is the x or the y? I personally think it's the x. And I'm going to do that by multiplying that top row by something. What number do you think I should multiply it by? Well, two great choices are either 3 or negative 3. So I'm going to multiply it by 3. So if I multiply that entire top row, every piece by 3, I get 3x plus 6y equals 12. And then I'm going to rewrite my original row 2, 3x plus 3y equals 10. Now, I'm going to add these two rows together. Actually, more specifically, I'm going to subtract the second row from the top row. So I can multiply by negative 1 and add. You might have thought, I should have just multiplied by negative 3 to start, but I wanted to show you a subtracting thing, because we can subtract as well. So now if I do the top row minus the bottom row, I get 3x minus 3x, x's are gone. I get 6y minus 3y, giving me 3y. And then 12 minus 10 gives me 2. And then I have y equals 2/3. And then I'm going to plug it back into my original row 1 right here to solve for x. I get x plus 2 times y, but I know y is 2/3, equals 4. I get x plus 4/3 equals 4, which is 12/3. And so x equals 8/3. And then I have the solution 8/3, comma, 2/3. How about this problem? What if we have 5x minus 4y equals 6, and then 3x plus 2y equals 8? Now, if I wanted to get rid of the x, just pretend I want to get rid of the x, what should I do? What could I do? Well, if I want to get rid of the x, I would multiply this top row by 3, and then I'd multiply this bottom row by what? Well, either 5 or -5. And then add those two rows together, right? I would get 15x minus 12y equals 18, and then -15x minus 10y equals -40. Now, do you see why I chose 3 and -5? How does that help me get rid of the x's? Well, basically, I needed these two numbers, right, these two coefficients to be the same. So I need to multiply by any two numbers that worked to make the coefficients the same. Like I could have multiplied the top one by 6 and the bottom one by 10, whatever, but I think you can see that when I chose 3 at the top and 5 or -5 on the bottom, I would have the same coefficient for x, or the negative of the coefficient. So I could get rid of the x. And then I can add these two things together. So 15x plus -15x equals 0x. -12y minus 10y is -22y. And then 18 plus -40 is -22. So y equals 1. And then I could go back and find the value for x. Now, if I had the choice, if I had to say, hey, I got to get rid of the x, I would have chosen to get rid of the y. I'll get the same answer if I do it correctly. How do you think we should get rid of the y in this problem? What is your idea? If you thought, let's multiply this bottom one by 2, so let's rewrite it on the left over here. 5x minus 4y equals 6. And then bottom row becomes 6x plus 4y equals 16. And then added them together, that's exactly what I would have done. It just seems a little bit easier to deal with. A little bit simpler, I should say, to get to the answer. I get 11x equals 22 because the y's disappear, and x equals 2. And then I could go back into any of these equations and solve for y, but I did that above. So I know the solution is 2, 1. All right. One last one. Let's make it a little bit more complicated looking. Let's say 3x plus z equals 10. And then y plus z equals -1. And then x plus y plus z equals 2. Do you have any idea what we could do to solve this one? There are many ways to solve it. What is your idea? Well, let me label this one as row 1, row 2, and then row 3. And it might help me if I put row 2 equals 0x and row 1 is 0y. Kind of fill those things in if you need to see it. Now, this is what I'm going to do. This is just what I happen to see here. What if I do row 3 minus row 2. That is, if I have x plus y plus z equals 2, so I'm moving that to the top just to make it a little bit easier for me to see. And then row 2, remember I said I can interchange where the rows are, but row 3 and row 2 are going to refer to the original. So I have 0x plus y plus z equals -1. Now what if I subtract the bottom one from the top? Well, I get 1x minus 0x. Okay, so I have 1x. I get y minus y, gone. I get z minus z, gone. Excellent. And then 2 minus -1, I know what x is. X equals 3. But if I know what x is, let's look at the original row 1. I know that 3 times x, or 3 times 3, plus z equals 10. So z equals 1. If I look at the original row 2, for example, I see that y plus z, but I know that z equals 1, equals -1, which means that y equals -2. And I have the solution to this system of equations, x equals 3, y equals -2, and z equals 1.